Hey friends, did you know that you can use Cosmos DB to build your AI apps? Kirill Gavrylyuk and James Codella are here to show me how today on Azure Friday. Hey friends, I'm Scott and it's Azure Friday. I'm here with Kirill Gavrylyuk talking about Cosmos DB for AI apps. How are you, sir?
Well, hi, Scott. It's great to be here. I'm really good, really excited about the AI apps folks are building, and obviously always about Cosmos DB.
So I understand that when you build an app for AI, oftentimes you're going to be augmenting what a very large language model or any model really has with data that you might have locally. So if you have a large language model that generates text, on top of that, you almost have like a delta or a series of vectors that augment that. I think that you usually have to get a vector database for that. Isn't that a custom special thing, another thing I have to buy?
I think what obviously we're learning every month about AI together. But what we've seen recently is that it is not really just about vectors, and you want to take advantage of your data and your vectors together and often do queries more complex than just vectors, but hybrid queries using both vectors and the native query engine capabilities of the database, for example. Um, let's maybe take a look at the few apps that everyone knows well that use Cosmos DB today and see how they are evolving and becoming intelligent, so to speak, or use LLMs. And maybe some of them don't really have to use LLMs to become intelligent. Um, let me uh, switch to a screen with the apps.
While you're doing that, that's a great point because most people are not going to start from a fresh app that they're going to build from scratch. They've got an existing application. They might want to sprinkle some AI in there and augment a section of their existing database apps with AI.
Most definitely. Let's start with the AI app that everyone knows, ChatGPT, built by OpenAI, launched early last year. Definitely very popular chat experience, very smart, very intelligent, knows about Azure Friday. Uh, this app uses Cosmos DB as a primary database. It stores all the data, starting from chats, prompts, responses, um, anything you upload to to OpenAI, files, images, anything, metadata about those things is stored in Cosmos DB. And when you look at what does it take to provide a chat experience and feed the right context to to the large language models that ChatGPT uses behind the scenes, it's two things. One is obviously the model itself is already trained on some data, but you want to provide a context of the prior chats, for example, prior messages, relevant messages uh, to the to the LLM. And so we have to produce vectors of the questions that I'm typing. Um, what is Azure Friday? And you have to correlate this, and the ChatGPT goes and looks into the history and wants to query the database for any relevant related chat dialogues that we had before and feeds the only relevant conversations together with a question to the LLM to get the most relevant answer. This is a classic retrieval augmented generation pattern in action. And here we're using the vectors, we're using these embeddings to help us find the most relevant information uh, where the data is in the database, and your vectors likely also it makes sense to store in the database. What database helps you in this case is ability to do a query, not only get me relevant all the chat messages that are like this by user ID equal foo from date X to date Y. So these hybrid queries are becoming very popular in the RAG pattern, which makes using the vector indexing built into the regular databases very attractive.
Yeah. And like what if I have my own documents, right? I might want to go and use what's called the RAG pattern to uh, index my documents, make sure that those can be queried as well, keeping that information private, but still allowing the chatbot to be able to talk about it. So we could maybe even feed all the Azure Friday episodes that it doesn't know about into this and chat about it.
Yep, definitely. Uh, let's take a look at another example. What's very popular these days is the enterprise chatbots because they're a little safer. We don't expose all of the enterprise data, and who knows what LLM will do. So it's a little easier to test and validate, a little safer to build these chatbots for the internal usage to make your workforce more efficient. For example, KPMG, as part of our Ignite, one of the Ignite sessions that we did on Cosmos DB, KPMG presented what they did with Cosmos DB as they built internal LLM agent, a virtual assistant called KimChat, that is aware of all the knowledge base of KPMG, aware of all the prompts. And this it's built on Cosmos DB, and it uses a RAG pattern, and it uses these hybrid queries to query not only the based on the nearest vector, but also based on other attributes and other expressions. And it uses databases are great at this when your application is really transactional, when the application needs performance, needs reasonable scale, and needs to take advantage of additional query engine capabilities.
Right, right. That RAG pattern is retrieval augmented generation, and retrieval is what Cosmos DB is great at. And there's a lot of things that the large language model knows, but there's so many things it doesn't know, and certainly it doesn't know about your data. And it's the combining of those things and those hybrid queries that makes the magic happen.
Yep, perfect. Now, of course, not every app necessarily needs to jump directly into LLMs. Or maybe feeding their data into LLMs. Let's take a look at another example that uses vectors and vector indexing in the database, but at the same time uses LLMs slightly different way, not directly with RAG. So here we have Asos.com. Asos.com, popular fashion website, good good dresses, especially if you have teenage children. Scott, you may relate to that. And so if I want to go to a Barbie movie, I would probably type something like, give me Barbie dresses. Um, but the text search won't know what does Barbie dress mean. I mean, it'll try to find Barbie dress. It doesn't know that Barbie dress means any pink dress, etc. This is where vectors play a good role. So Asos uses vectors, has been using vectors for a while to augment the concept of nearest neighbor, nearest record to a given prompt with this vector similarity capability. And because it uses Cosmos DB for everything, for example, if they're building a virtual assistant, they will want virtual assistant to be aware of not only about their catalog, but also about the content of their shopping cart, for example. So now we're talking about a real-time RAG, where it's important to have the data and the embeddings consistent in the same place, as opposed to kind of using a separate vector service, vector database that is far from your data and may not be up to speed on the latest changes and the latest items that I just added to my shopping cart. So that's another example of.
So if I understand correctly here, classically in a catalog situation, if you search for Barbie dress, it's going to look for the string Barbie appearing in the metadata, in the description, in the title. And in this context, none of that exists. There is no customer management, no CMS organizer went in and wrote Barbie anywhere. It knows that a pink dress and a Barbie dress may be synonymous. And while pink is objectively pink, Barbie is subjective, and it's the vector that made that connection and allowed you to search for something that they couldn't have expected you to search for, and the customer still had a great experience.
Yes, precisely.
That's cool.
Now let's remind folks what behind the scenes. How does one build an experience like this with Cosmos DB today? You may have your data already in Cosmos DB, or you may have in some other data source, but you want to use Cosmos DB for its scale, performance, latency. After all, vectors is just another data type. If you want to take advantage of the database characteristics, you store vectors in the database. So in this case, the data is already in Cosmos DB or being fed into Cosmos DB from other sources. The user asks a question or otherwise calls an API to search. Based on, we produce a vector using, for example, OpenAI embedding API to get a vector based on the algorithms that OpenAI understands for a prompt. Once we have that vector for a prompt, we can use the nearest search capability, the vector index capability in Cosmos DB, today present in Cosmos DB for MongoDB vCore, and later this spring will be extended to all APIs. Uh, we will perform a query and get the all the most relevant entries in the Cosmos DB based on the prompt. And then we can ask a question already augmented uh, to LLM, augmented with context, and get a more relevant answer. This is a typical kind of retrieval augmented generation pattern. In this case, we're using vector capability of Cosmos DB built in. Also, we see customers using building their own vectorization pipelines. For example, in this case, we use ChangeFeed and we use Azure Functions to update embeddings in the Cosmos DB as the data changes coming in and streamed into the database. Many variations of this pattern, but the apps that I've showed just showed those three apps largely follow the same steps, the same practices with few variations.
Very cool. So this means that people are going to be able to take their existing databases, and it's going to be very comfortable to implement the RAG pattern, taking existing apps and adding AI. But if you're new to Cosmos DB and you're bringing all of your application to it, we're ready for you and any of your large language model powered scenarios.
Yep, precisely. Now let's maybe ask James to show us what different capabilities, how do I build it with Cosmos DB, and see how easy it is to build such experience with Cosmos DB today over your data.
Fantastic. Welcome, James. Thank you, sir.
Hey, Scott. Really happy to be here today. Yeah, so we have a lot of really great resources to get you started to quickly build applications using Cosmos DB and powering your large language models. So what I have shown here is a repository that we have up on GitHub that has lots of different examples and tutorials for getting you started. So I'm a Python guy, so we have here a Jupyter notebook that walks you through basically a really simple RAG pattern all in a Jupyter notebook. So if you're new to OpenAI, if you're new to Cosmos DB, this is a really good playground for you to get comfortable with using the APIs and using the tools. And then also, checking out what's going on with your data, checking out what's going on with your vectors and with your GPT models, right? So it walks you through the entire setup of installing the preliminaries, setting up your resources, creating embeddings from a sample data set, connecting to Cosmos DB for MongoDB vCore. And for Python folks, you can use the PyMongo package, which is great. Scott, I know you're a .NET guy, so you can use the MongoDB NuGet package. And we have a .NET example here in the repo as well. So it walks you through, setting up your index, uploading your data, doing a sample vector search, and then even starting a little Q&A loop over a GPT 3.5 model, which is what powers the original ChatGPT. So with this data set, you can basically feed some information about all of Azure services, and so you'll be able to ask ChatGPT about Azure services and get some more information there. So some really great resources here to get you started, at least in a simple, small prototype.
Yeah, I'm always so impressed with this. I've talked to Kirill before this on previous episodes where I had a Node application that talks to Mongo, and I plug it into Cosmos, and it doesn't know it's Cosmos, but Cosmos does it. And what's so great about Cosmos, and we keep repeating when you guys come on to Azure Friday, is that it is really the world database in scale. And whatever kind of data, whatever shape of data you want to throw at it, it's ready for it, which kind of blows me away because I thought to do this kind of vector work, to do this kind of AI work, I would need to go and get something else. And here the database I'm already using is ready to go.
Yeah, that's right. Yeah, it's really powerful. It just simplifies your entire orchestration and even maintaining all your services when I can just have one service that does everything for me. Um, so this example, like I said, is really simple, but we actually have something a little bit more complex. So we also have what we call our solution accelerator. And what this does is it puts up a bunch of Azure resources through an ARM or bicep template. There's a quick deploy button down here. If you scroll past some of the starter information about what this solution accelerator does, but I'll just scroll all the way down and see if I can find it here. Here we go, deploy to Azure. So I can read through this tutorial and know that this will set up a demo for me for the Cosmic Works bike shop, right? So imagine that I'm a e-retailer that sells bicycles and I want to create a LLM chatbot application to help my customers decide what is the right bike for them. So by clicking this button, I can literally have like a one-click, maybe a few more clicks for setting up a couple of resource names, but pretty much a one-click experience for setting up this demo and all the resources in Azure that are together. What this does is deploys some .NET applications and Azure functions, deploys your Cosmos DB resources, your Azure functions, all of your orchestration together. So you can actually have this chatbot demo that looks kind of like this here. You have this nice little web app, and you can go and interrogate and ask questions for ChatGPT and all about this bike store. And again, this is based on the exact same solution architecture diagram that Kirill had just shown for a simple RAG application. Like you can take this, you can learn from it, you can use it in your own applications, you can modify it, and go have fun with it. So really sort of powerful, sort of next level to get you off of the, hey, I'm experimenting in a notebook to, hey, I want to create a POC pretty quickly and get some feedback from my customers, get some internal feedback from my testers.
Just out of curiosity, are you, and this is a little bit off topic, but are you using type chat or any of the libraries to talk to this, or semantic kernel, or are you just calling the APIs directly?
Yeah, so this example uses semantic kernel to handle some of that orchestration. But
Cool.
what I'm going to show you next actually uses Azure OpenAI Studio, which has a lot of great integration capabilities in it as well. So let's go over to that. So the behind the scenes work that I've already done is I've already set up a Azure Cosmos DB for MongoDB resource. I've already loaded this Cosmic Works data set. So I already have all my bike information there, and I've already created vectors using the OpenAI embeddings Ada 2 model that characterizes, descriptions of all the bicycles that are in my bike store. But let's go to Azure OpenAI Studio. So some of you may already be familiar with this. You may have used it a lot, done a lot of experimentation, right? You can manage all my models, and I have my nice chat playgrounds here. And that's what we're going to take advantage of today. We're going to use the chat playground, and we're going to use this experience called Bring Your Own Data, which helps me do RAG in pretty much like a no-code environment after I get my data in my database already. So let's go ahead and click the Bring Your Own Data card. And right away, this brings me to the playground experience. And I can add my own data source here, right? So there's lots of different options to choose from that have integrations with Azure OpenAI Studio. I'm going to choose Azure Cosmos DB for MongoDB vCore. And I've done this already, so I have my subscription in there. I'm going to choose my database account, and there's quite a few in there. So let's see if I can quickly identify. There we go. That's the one that I want. And then you enter in your authentication information, right? So I've done this already, super secure. Then I'll click next, and I select what database I want to use to power my ChatGPT model, right? So I'm going to choose my Retail DB database. I choose my collection in Cosmos DB, and it's my products collection. So I want to ask questions about the products in my data set. And then I have to choose an index, right? So in MongoDB, I specify in Azure Cosmos DB for MongoDB vCore, I specify indexes for how I want to query my data. And vector index is just another type of index that you can create. So I already have one created. It's called the vector search index. And then, as Kirill mentioned, like as part of this RAG pattern, the questions and prompts that I send to my GPT model, to my chatbot, those have to be vectorized so I can do the vector search against the data in my database. So to do that, I need to connect it to a embeddings model that I have deployed in Azure OpenAI. And I have just such a model here. And then I just acknowledge that, I'll incur usage charges for that model, which is totally fine. And then the next thing I need to do is just tell the interface what to look at when it does the vector search. So I'm going to say, when it does the vector search, I want it to pull up my category name of the bike, maybe a name, a price, the SKU for my bike, description of the bike. And give it, I want it, when it references a title, I want it to take the name of the bike. And then I'm going to tell it, if when you're doing vector search, look for the vectors in this field called vector. And There we go. Just with a few clicks, I have this all set up here. And now this is linked to my data. And I can play around with a couple of settings here to make sure that I'm going to get the experience that I want. And I've already populated this with a system message. So the assistant that we're going to create here is called Wheelie. Wheelie has no relation to Clippy, maybe a little bit relation, maybe a long distant cousin or something. But Wheelie, we're going to say, Wheelie, you're an AI assistant for Cosmic Works Bike Store, and here's some other information as well to sort of help dictate the behavior of my model. And so then I can get started. So I can say something like, hello, what's your name? And so by asking this question, what I'll do is I'll verify that the LLM is actually taking in my prompt data, my system message data, and actually using that as an instruction to respond to me, right? So, hello there, my name is Wheelie, et cetera, et cetera. And so it seems to be ingesting my system message appropriately. So let's see if it actually knows some information about the bikes that I have in my bike store. And what I'm going to do here is I'm going to make it a little bit more fun. So I'm going to go to the playground settings, and I'm going to connect this to a Azure speech resource. So I'm going to enable speech to text and text to speech and choose a persona voice here. And hopefully this will come through here, but let's see if we can do it this way. So I'm going to leverage Azure Speech Services and talk to my Wheelie chatbot and see if we can find some bikes for me. Hey, Wheelie. I'm a guy who lives in the New York City area. I love to go on bike rides in the city, but it's cold right now because it's winter. Can you recommend some bikes for me? And then we'll send that to our large language model. We can see it didn't get Wheelie quite right, but Willie is pretty close.
And I noticed that it's populating the references. And while it's bringing it back, I want to call out a couple of things that people may not have noticed that you did that were significant, that I think were pretty cool. First, you adjusted your strictness, which grounds your model in a little bit, trying to focus on the things that we care about. We don't want this to be offering advice about things that aren't bikes. We don't want it going off the rails and talking about anything other than what it's grounded in, which is bicycles. But the second thing that you did I thought was interesting is that you chose Ada as your model rather than Babbage or Curie or Da Vinci, one of the larger models, because it's just not necessary to have a very, very, very large language model to do something as simple as a chatbot like this. And in doing that, you're giving yourself speed, you're saving yourself money, and the customer gets a great experience, whether you're on ChatGPT-4, which is in this example unnecessarily expensive, or Ada, which is a nice, crisp, small model that accomplishes what we are seeing is a really great experience.
Yeah, so again, like this is compatible with any Azure OpenAI model, right? So as you experiment, which is necessary for any AI or machine learning project, even with the fantastic power of LLMs, you need to do some experimentation, you need to do some testing and validation. This is compatible with any of the models there. So if you want to do some experimentation and see what is really the best for your scenario, the best bang for your buck, the most cost effective, you're empowered to do that.
Very cool.
So I'm not sure if you heard what I heard, which is maybe it's because my audio is not hooked up, but I heard Wheelie talking to me about all the options that are here.
Sorry.
As I said
Because
into
you're
it.
not routing your audio output from your browser into your
Okay.
microphone. If it was speaking to us, we did not hear any of that.
Okay.
So it
Cool.
sounds
Well,
like Azure OpenAI Studio talks back to you if you talk to it.
that's right. That's right. Yeah. So the same way as I talk to it in the same playground settings that I have here, I enabled speech to text and text to speech here. So Wheelie can come to life and speak back to me, which is really powerful and really fun here. And then I can ask some further questions, or I can say. Hey, Wheelie. My friend Scott here lives in the Seattle area. And Scott, I'm going to assume some things about you that you love to go biking. Maybe you love to go mountain biking. Maybe you like to really be in the hilly terrain, really hard, difficult terrain for biking. So, Wheelie, do you have anything for my friend Scott here? And we'll send it off to Wheelie. And we won't wait for the.
Yeah, unfortunately, I live in Portland, but we're still bicyclists. So you're
Ah,
close there. We'll get some Northwest appropriate responses here.
well, so really says that Seattle has a beautiful hilly terrain, which is true, and I know that Portland is also extremely beautiful. He's recommended some mountain bikes here, and what's really great is like there are some characteristics that are mentioned in the descriptions about attributes of the bike, and the large language model is able to take that and map this to its understanding of the scenario that I gave it in the prompt and really bring sort of the contextual relevancy from these items like to the experience. It's really powerful, really impressive.
And then can you open up the references that is currently closed with a chevron?
Yeah, I can actually. So this is really cool. So I can see the references of what it's looking at in my database, right? So if I click citation one, I can see exactly. So if you recall, when I was setting up the data in in the Add Your Data experience, I listed all those properties of my products in my database that I wanted it to reference, and that's exactly what it's doing here. Like it's referencing like those items. So this is a neat way of being able to guarantee or validate that what is coming back from my LLM is actually tied to data that's in my database. It's pretty cool.
So it sounds like I do my experimentation here. Like you said, I can use any model I want. You started with Ada. We can tune the model. We can pick the model that's appropriate. We can certainly adjust the response. We can adjust the citations and the reference. Then I assume that I graduate from the chat playground into an IDE or a code editor like Visual Studio Code.
Yeah, exactly. And Azure OpenAI Studio already has you covered for that, right? So I can click on this View Code button here, and I can see some sample code that basically has the same sort of experience, um, you know, in the language of my choice already implemented for me. All the parameters that I set, all the connections to my data, all the system prompts that I gave it, it's already here. And I can choose whatever language I want. I can say in Python, there's a C sharp example. I can use curl and query the API directly. Then I have my credentials and endpoints here. So it makes it really easy just to copy my setup over to my IDE and then get started in my own application. But there's
Very
even something it's even something cooler if I want to actually skip the IDE, staying with this sort of low code, no code experience. There's a deploy to button in the top right here. And if I click that, I can deploy a completely new web application. And this will create a cool web application experience for me to get started. And once I deploy this app, it takes about 10 minutes, so I'm not going to show it here. But once I deploy this web application, I can actually share this. I can share this with a group of beta testers. I can share this internally as a POC, and I get this rich web-based experience in an application that's just set up for me auto magically. And then there's a great option down here which says enable chat history in the web app. So one use case that we're seeing for thousands of Cosmos DB customers today is when customers build a chatbot, especially a chatbot with large language models, they want to keep track of the chat history. They want to know how customers or users are interacting with the chatbots. They want to know how can I make this interaction with my chatbot even a richer experience? How can I make this experience better? But if I'm an e-retailer, I also may want to know what kind of questions or what kind of products are my users asking about. Or if I am in a regulated industry, like in the financial industry or healthcare industry, like I may want to keep records for auditing purposes, for regulations and for guidances, right? So we're seeing lots and lots of users use this today. It's incredibly easy. I just click a few checkboxes here, and my POC application starts collecting chat history for me to analyze later.
Very cool. So, in the remaining few minutes that we have here, maybe we can fast forward to where I would get started, and maybe there is some accelerators that could actually fast forward my experience.
Yeah, absolutely. Like I mentioned, there we have some great resources that you can actually check out on our blog about the general availability of vector search and Azure Cosmos DB from MongoDB vCore. So it lists all the new features that we showcased here today, tells you about performing the vector search and all the tools to integrate with LLM orchestration mechanisms like semantic kernel, LangChain, Llama Index, and Azure OpenAI Studio, which I just demoed here.
So I should start at the blog, and then that will lead me into the GitHub and the different things where I would get the sample code and the accelerators that I need.
Yeah, exactly. All the resources that you need are at your disposal there on the blog.
Very cool. Well, thank you so much, James Codella, and our original host there, Kirill Gavrylyuk, teaching me how to enable AI applications with Cosmos DB. We're ready to go. I'm going to go and see if I can sprinkle some AI on some of my existing Cosmos applications. Thank you so much for hanging out.
Great. Thanks for having me, Scott. And I'll mention a quick teaser is that we're getting vector search in Cosmos DB NoSQL coming soon using the powerful disk-ANN algorithm, which is developed at MSR. So really great stuff coming in the pipeline for Cosmos DB NoSQL.
Very exciting. I am learning all about how to use Cosmos DB to build my AI apps today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.